And for a Doppler profiler, even at 1 hertz sampling, which is about as fast as you can drive one of these, the data bandwidth is actually really low. Imaging sonar is a little worse. The acoustic array is a little higher. Stereo optical really blows you through the roof. But to do species identification, you need something at that sort of bandwidth, so either imaging sonar or optical imagery. So this basically drives you toward the need to have a cabled connection to shore, which is really hard to do in these wave and current environments, right? I mean, it's tough. It's high energy tides, high energy currents, high energy waves. So trying to deploy one of these packages with its own cable is really tough. So we need a cable, but fortunately, the marine energy converter also needs a cable to shore. So what if we were to integrate some of these packages themselves with the converter? What might that look like? Well, here's a picture of an open hydro turbine, a 6-meter variant, with the amp installed on this cantilever sticking off the turbine. So the amp is able to make use of the power and data cables that go back to shore that are combined with the that are basically used to take that power back to the shore station. And that gives us both the data bandwidth we need to run the monitoring mission and the power to run those sensors. Okay, so that's great. But let's say we want to put a new sensor in. Let's say we have a sensor failure, and we want to change the monitoring mission, or we learn something about how fish are interacting with the rotor, and now we want to see how they're aggregating, so we want to turn this thing. Well, one option is just bring the whole converter back to the surface. That's about $1 million operation, and it's not exactly low risk. So that's probably not a good idea. So we need to figure out some way to actually get this back and still have it be able to connect down into the turbine without actually bringing the whole thing back to the surface. Okay, so we've been thinking about that as well. And this is a system we've come up with. So the system you're seeing here, the amp is in the center here.